Dear students, welcome to EPG Pathshala. Today in this module, we will be discussing about an energy from waste process, biogasification. Now you all know waste treatment is one important step in a waste management plan next to waste collection. Now without a proper treatment, the waste, if it is disposed of into the environment, it will cause a lot of environmental and health hazards, posing a lot of risk to the human beings and animals. So to have a proper treatment, there are various methods which has been proposed, starting from your thermal treatment, chemical treatment, advanced thermal treatment and the biological conversion route. In the thermal treatment, it involves the conversion of waste or burning of waste in the presence or absence of oxygen at a very high temperature. Example is your incineration, where you combust the waste in the presence of air at a very high temperature of 900 to 1100 degrees Celsius. On the other hand, advanced thermal treatment technologies like pyrolysis and gasification, it is done at high temperature in the absence or the limited supply of oxygen. The other treatment method, that is the biological conversion route, nothing but the examples can be the biogasification, anaerobic digestion, composting and vermicomposting. They involve microorganisms to treat the biodegradable fraction of waste. Now the biodegradable fraction of waste contributes almost 60 to 70% of your total waste. So if you segregate them and then treat them or apply any biological conversion route, so a maximum amount of waste can be treated and reduced, as these methods are safe, eco-friendly, as it does not release any other harmful chemical contaminants or intermediate products into the environment. Now in this module, we will discuss about biogasification, which is again a biological conversion route where the biodegradable fraction of waste is subjected to anaerobic microorganisms, and through anaerobic process it is converted into a valuable product called as biogas. Now why it is called as energy from waste process is that the biogas that is generated at the end of biogasification can be used or converted into electricity. With this introduction, now let us look into the learning objectives of this module. The learning objectives of this module include to understand the process of biogas generation, to study about the types of biogas plants that are used in biogas generation, to gain knowledge about the factors that influence biogas generation, and to realize the various merits and demerits of the process. Finally, we will also gain some knowledge about the limitations of this biogas technology. Now what is biogas? Now biogas is a gas that is produced during the anaerobic degradation of organic matter, manure or waste material. It comprises of methane, carbon dioxide and other trace gases that are produced by the process of biogasification. Now this process is also termed as methane fermentation. In the earlier times, the biogas was produced from cow dung or any decayed plant material. Later, in addition to cow dung and the plant decayed matter, other cattle dungs and animal material, food waste, kitchen waste, biomass, sewage, manure and green waste were explored for biogas generation. Now the large scale application of biogasification process was used in wastewater treatment, especially to treat the sludge that is being generated from the wastewater treatment process. Now the application of biogasification specifically to municipal solid waste was started in the year 1930s to 1940s with a purpose to stabilize the waste and to recover energy from the organic fraction of waste material. Now municipal solid waste contains a lot of abundant chemical energy in the form of carbon. So this can be potentially utilized to produce a fresh source of energy. Also this will reduce the amount of waste that has to be taken to the landfill, thereby increasing the life of the landfill and reducing the space in the landfills. Now, let us discuss about the process description. Now, the biogasification is done by the anaerobic process. Now, the anaerobic process involves 4 steps: 1 hydrolysis, 2 acidogenesis, 3 acetogenesis, and finally it is methanogenesis. The hydrolysis involves a facultative anaerobes and it converts the carbohydrates into sugars, proteins to amino acids and ammonia via deamination and lipids to fatty acids and glycerol. Now, the gas production at this stage can go up to 80% of carbon dioxide and 20% of hydrogen. Now, in the acetogenesis process, it converts the organic acids into the volatile fatty acids and further into acetic acids and its derivatives like carbon, carbon dioxide and hydrogen. Now, in the acetogenesis process, the acid stage, it is also called as the acid stage, that involves the acetogenic bacteria. Now, some microorganisms in this stage convert the carbohydrates into acetic acid in the presence of carbon dioxide and hydrogen. The end of this stage is marked by the decrease in hydrogen and carbon dioxide levels. The last stage in the anaerobic process is methanogenesis. Now, in this phase, the methanogenic bacteria convert the acetic acids and its derivatives into carbon dioxide and methane. Now, the methane generating microorganisms are promoted only during low hydrogen levels. There are 2 groups of microorganisms that are active during this stage. One is your mesophilic bacteria, which are active in the range of 30 to 35, and the thermophilic bacteria, which are active in the range of 45 to 65 degrees Celsius. Now, the gas that is produced during this process comprises of 60% of methane and 40% of carbon dioxide in addition to certain trace gases. Now, this figure illustrates the schematic of the 4 different processes which are involved in the anaerobic process. Now, as you see, the hydrolysis process involves the hydrolysis or the conversion of complex materials like carbohydrates, fats and proteins to sugars, fatty acids and amino acids. And next, they are converted into the acetic acids, carbonic acids and alcohols with the release of hydrogen and carbon dioxide. Now, during the acetogenesis phase, these products are converted into acetic acid and carbon dioxide. Finally, at the end of methanogenesis process, the acetic acid and the carbon dioxide, they are converted into methane and carbon dioxide. Now, let us discuss about the various microorganisms that are involved in the biogasification process. Now, according to the different process, you have a different set of bacteria that is involved in the anaerobic process. In the first stage, you have a lot of hydrolytic bacteria which helps in the breakdown of the complex substances like the cellulose, hemicellulose and other materials into simpler substances. Among the microbial population, 90% of the population belongs to the acidogenic bacteria group. They degrade the polymers to acids and acetates and facilitate easy utilization of the substrate by the methanogenic bacteria at the last phase. Now, the acid formers generally grow vigorously and tolerate a wide variety of environmental conditions. On contrary, if you see, the methanogens are slow growers and they require very less nutrition. They rely on polymers and the acid stage for carbon and ammonia for their nitrogen needs. And if you see, these methanogens are very sensitive to pH and hydrogen. Now, the atmospheric oxygen is again one important factor that again affects the growth of methanogens even at low concentration. Nitrates and nitrites also inhibit the growth of methanogens, and the optimum pH that is required for the survival of methanogens is 7. Now, they have a tolerance pH tolerance in the range of 4.5 to 8. Above this or below 4.5, they cannot survive. Now, the methane producing bacteria, the methanogens, generally transform the acids by 2 types of reaction. One is the fermentation of short chain fatty acids and some alcohols respiration, in which hydrogen, carbon dioxide and certain simple organic compounds are oxidized anaerobically coupled with the reduction of carbon dioxide to methane. Now, if you see in this equation, now acetic acid is converted into methane and carbon dioxide, and the methyl alcohol is again converted into methane, carbon dioxide and water. The production of methane through respiration involves the incomplete oxidation of alcohol to acetic acid, which is coupled with the reduction of carbon dioxide and methane, which can be exemplified by the reaction, and it is performed by a bacteria called as methanobacteria omelianski. Here the methyl alcohol and carbon dioxide, they react to give the acetic acid and methane. The reduction of carbon dioxide with molecular hydrogen is given in this equation. Now, let us look into the composition and the properties of biogas. Now, the biogas as such, if you see, it is composed of 55 to 65% of methane, 34 to 44% of carbon dioxide. In addition to that, as I told you earlier, it also contains some trace gases like the hydrogen sulfide, molecular nitrogen and water. Methane, hydrogen and carbon monoxide can be used as a fuel. So, that is why it is a energy from waste process. Now, the heating value of the biogas ranges from 18,630 to 26,080 kilojoules per meter cube. The biogas should be free of hydrogen sulfide, so that the corrosion in the engines can be avoided. Now, the biogas, when it is cleaned, compressed and used as natural gas, they are termed as methane, and they are brought to the natural gas standards. Now, in this table, if you see, on the left side the composition of biogas is given, and on the right side the features or the characteristics of biogas is given. Now, composition as such, if you see, methane contributes or is comprises of the biogas comprises of 55 to 60% methane, 35 to 40% carbon dioxide, 2 to 7% water, around 2% of hydrogen sulfide, 0.05% of ammonia, again 2% of oxygen, nitrogen and 1% of hydrogen. The characteristic feature as such, if you see, the energy content of biogas ranges between 6 to 6.5 kilowatt hour per meter cube. Now, it is equivalent, the fuel equivalent is 0.6 to 0.65 oil per meter cube of biogas. The explosion limit ranges from 6 to 12% in air. Ignition temperature is 650 to 750 degrees Celsius. The critical pressure is 75 to 89 bars, and the normal density is 1.2 kg per meter cube, and the smell, like it smells like a rotten egg. Now, in addition to the biogas, you also have certain residues that is left out at the end of biogasification process. The digested sludge left after the release of combustible biogas make up the residue. Now, it consists of two major components, the supernatant as well as the settled solids, which is generally termed as sludge. Now, the supernatant contains a mixture of suspended colloidal solids and other bacteria in suspension. Now, these solids are biodegradable and they remain unstable. So, again they need to be treated properly before being discharged into the environment. Generally, what do they do is, a portion of the supernatant is either used in slurry preparation or it is recirculated back to the digester. Now, the recirculation can help in maintaining the microbial population within the digester, and it will help in complete degradation of waste, and it can also be utilized as a source of nutrients. The remaining supernatant can be discharged into the land. Now, when you talk about the sludge, they can be dewatered or spread on a sand bed to concentrate the solids. Now, the dried solids are once again used as a manure in agriculture fields. Now, let us discuss about the various biogas plants. Generally, there are three types of biogas plants are used for biogas production. One is the balloon type biogas plant, second is a fixed dome type, and the third one is a floating gas holder type biogas plant. Now, in a balloon type biogas plant, the digester is made up of heat sealed plastic or rubber bag with an inlet and an outlet. The material used in balloon construction should be weather and UV resistant. You can also use reinforced plastic, red mud plastic, trivia and butyl for constructing or fabricating the balloon type biogas reactors. Now, the balloon functions as a digester as well as a gas holder. Now, it acts like a fixed dome plant when the gas space inside the balloon becomes full. The movement of balloon skin helps in agitation of the digester contents. So, agitation, as we all know, it generally increases or favors good gas production. Now, the balloon must be provided with safety valves to avoid damage of the balloon skin. At increased gas pressure, the balloon skin gets damaged, and the entire lifespan as such, if you see, it ranges from 2 to 5 years. Now, let us discuss about the advantages and disadvantages of the balloon type biogas plant. Now, advantages as such, if you see, it is very cheap, economical, cost effective, low fabrication cost, ease of transportation, and they can be installed in shallow and suitable areas where the groundwater table is high. The cleaning, emptying and maintenance of these digesters are very easy, and feedstocks that are difficult to digest can be used in this type of digester. Now, the disadvantage as such, if you see, the gas pumps are required during low gas pressure conditions. Second, you have scum formation within the digester which cannot be removed during operation. Now, lifespan of the plastic balloons is very short, and it needs frequent replacement. Now, balloons are also more susceptible to mechanical damage. Now, balloons are not locally available, and they are not recommended in place where the temperature is even or high. The second type of biogas plant is a fixed dome biogas plant, which is generally a cemented structure with a central digester tank fitted with an inlet and an outlet chamber. Now, the feed is mixed with the required amount of water in the form of a slurry, and then it is added into the digester. The digesters are generally constructed below the ground to avoid the influx of air into the reactor and to maintain the anaerobic condition. After mixing, the contents are fed into the digester through an inlet chamber. Now, this inlet chamber should be slopy so that the contents move easily into the digester, and they are generally constructed underground. The digester is a huge tank with a dome like ceiling fitted with an outlet valve. Now, this dome like ceiling will act like a storage place for the biogas that is generated in the unit. Now, the biogas that is generated will be collected through this outlet that is fixed onto the dome. The digester contents, which is called as a spent slurry, is pumped out through an outlet chamber into an overflow tank. Now, the reactor is operated generally under batch conditions, where the digester is partially filled with slurry and it is left idle for almost 2 months. Now, this image shows a fixed dome type biogas plant, where you can see the digester is constructed below the ground, and you have an inlet and an outlet through the inlet your slurry is mixed and then dropped into through which through a slopy layer it slides into the digester, and it is left idle for 2 months. And you also have a dome shaped structure where the biogas that is being generated will be collected in this area, which is fitted with an outlet valve, and through this outlet valve you can collect the gas. And on the right side, if you see, you have a overflow tank or a outlet valve, where outlet chamber as such, if you see, where due to pressure the slurry or the digestate, which is after digestion, is taken off to the overflow tank, and from there the residue is collected. Now, what happens inside the digester, the process that occurs? Now, during this period where it is left idle for 2 months, the anaerobic bacteria hydrolyzes the waste and ferments them. Subsequent to fermentation, acidogenic and methanogenic bacteria, they start decomposing the waste and they will generate biogas, and this biogas will be collected in the dome. As more and more gas gets accumulated, I told you, in the dome, a pressure is built in the system. Now, due to the pressure, the biogas forces the spent slurry into the overflow tank. Now, from the overflow tank, the slurry will be removed, which I explained in the figure. Now, the reactor should be continuously fed to obtain continuous gas supply. Now, the volume of the fixed dome biogas plant is around 5 to 200 meter cube, and the biogas generated it is not so very high than 20 meter cube. the pressure that is maintained or which remains there within the digester will be around 60 to 150 millibar. Now, what are the advantages of this reactor? Again, it is cheap and cost effective, they can be constructed easily, the plant is cheaper than the floating drum plant by 20 to 30%. I mean the cost is reduced by 20 to 30%. The durability of the plant is more and it can stay about 20 years, unlike your balloon type biogas plant. The cost of construction and maintenance is also low. The disadvantage as such, if you see, it requires more excavation work and it shows low reliability. Now, the third type of biogas plant is a floating gas holder type biogas plant. Now, the floating gas holder type biogas plant, it consists of two chambers, inner and the outer chamber, and it it consists of a two chambered underground digester. Now, it will have two layers, inner and the outer layer, and it is generally fitted with two long cement pipes, one is the inlet and the other is the outlet pipe. Now, similar to a fixed dome, the floating gas holder biogas plant also consists of a mixing tank where the feedstock and the water is mixed, made into a slurry before it is being added into the digester. Now, mixing tank is always located above the ground level. From the mixing tank, the contents are added. The slurry, once it is added, it is left idle for 2 months for decomposition of waste and biogas generation. The gas that is being generated is collected in a drum like structure and that is inverted over the digester. In a fixed dome, it is a fixed inverted cylindrical drum like structure. Here it is floatable. As and when the gas is being produced, the dome is pushed and this is an indicator that the gas is being generated within the drum. The drum is generally made up of steel and it keeps moving up and down depending upon the amount of biogas that is generated inside the digester. Now, this image shows the floating gas holder type biogas plant where you can see on top of the digester you can see a cylindrical drum like structure. Now, as and when the gas is being produced, this drum keeps moving, that is why it is called as a floating gas holder. Same way the other arrangements are all similar, you can have an inlet and an outlet pipe and the gas that is being generated it's stored in this floatable dome and through an outlet pipe it is collected. Now, other things are all same, you have a mixing tank where the feedstock and water is mixed, made into a slurry and the slurry enters into the digester, and the digester is always located underground while the mixing tank will be above the ground. Now, what are the advantages of the floating dome type biogas plant? Now, it requires less excavation work, constant gas supply you can get, the system is highly reliable. On the other hand, they are very expensive and it requires high capital and maintenance cost that would act as a disadvantage of this type of biogas plant. Also, the drum tends to rust. Moreover, the durability of this type of digester is very low. Now, let us discuss about the various factors that will influence the biogas generation process. Now, let us start with pH. Now, pH plays a significant role in the generation of biogas. Now, as such, if you see during the anaerobic process also, wherever we have discussed, you have there is a lot of changes in the pH during the process. Like in the acidogenesis phase, the pH is very low due to the generation of volatile fatty acids. With the end of acidogenesis and acetogenesis phase, the pH keeps increasing and it reaches up to 7 or 8 when the methanogenic bacteria actually starts growing. So, during fermentation, when huge amount of organic acids are produced, the pH will drop below 5. At pH below 5, the methane formation cannot happen because it inhibits the growth of methanogenic bacteria. Now, pH rises at the end of acidogenesis process and it will go up to 7.2 to 7.5, making it a favorable condition for the growth of methanogenic bacteria. At certain times, what happens is the ammonia concentration acts like a buffer and it will increase the pH to 8.2. At this condition, high methane production can be achieved. Also, when feedstocks are used, they should have a pH in the range of 6 to 7. The other factor is temperature. Temperature also greatly influences your methanogenic process. Now, the rate of methane production gets increased with increase in temperature. Now, when temperature is increased, it also causes accumulation of free ammonia inside the reactor. As I told you earlier, the methanogenic stage works in two conditions, one is mesophilic and the thermophilic stage. The process of fermentation and the growth of methanogens are enhanced in a temperature range of 29 to 41 degrees Celsius at mesophilic range and 49 to 60 at the thermophilic range. Temperature fluctuation inside the reactor, it should not exceed more than plus or minus 1 degree Celsius for mesophils and 0.5 degrees Celsius for the thermophils. The next factor is pressure. Now, the pressure required for enhanced biogasification ranges between 1.1 to 1.2 bar. The next parameter is the loading rate. Now, the loading rate is defined as the amount of raw material that is fed into the digester, I mean the per unit volume of digester per day. It should be around 0.2 kilogram per meter cube for digester capacity. It should be around 0.2 kg per meter cube of digester capacity, and that will give better biogas production. Now, overloading or overfeeding can inhibit the methane production. Hence, it is essential that you optimize the solid waste loading rate in the digester. Now, limited or low feeding again can lead to low gas production. The next important parameter that influences the biogas generation is your solid concentration. Good biogas generation is achieved at a solid concentration of 10%. The ratio of solid to water should always be maintained as 1:9. The reactor should be fed at the same time every day to maintain the solid concentration. Moreover, when the solid digestion occurs, cow dung is also added to the digester in the ratio of 1:1. This will add to the inoculum and also it will maintain the solid concentration within the digester. The next factor is the retention time. The retention time for the biogas digester will range between 35 to 50 days. In batch reactors, the time is distinct, whereas in the continuous mode, it cannot be maintained properly. Complete digestion is achieved at longer retention time. So, longer the retention time, more complete is the digestion, but at longer retention time, it requires a bigger size digester, which becomes a disadvantage. The next parameter is the C/N ratio. Carbon to nitrogen ratio should be generally maintained within 30:1. Also, minimum of 2% phosphorus is required to have a better or enhanced biogas generation. Any alteration in the carbon to nitrogen ratio will lead to loss of fertilizer quality and low methane generation. For example, at conditions of very high nitrogen and low carbon, the carbon is consumed faster and the bacterial cells will starve to death due to non-availability of carbon. Nitrogen in the dead cells will return back to the solution, thereby adding to the nitrogen content in the digester. The next parameter is the nutrients. To achieve better biogasification, nutrients like nitrogen, sulfur, phosphorus, potassium, calcium, magnesium are all required in addition to copper and oxygen. Trace elements like manganese, molybdenum, cobalt, zinc, nickel and selenium are also required for better bacterial growth. So, if bacterial growth is better, then the biogas production will also be better. The next parameter that influences the biogas production is your water content. The water content should be 90% and it should be continuously maintained within the digester. Now, water content will depend on the nature of substrate to be digested. So, too much of water will again reduce the gas yield per unit volume of reactor. Likewise, if you have less water, the volatile fatty acid starts accumulating and it will hinder the pH and the pH will get drastically reduced. Also, this will result in the formation of thick scum during low water content. The other factor is the nature of feedstock. Now, nature of feedstock determines the biogas production. If the waste materials that are rich in carbohydrates and sufficient proteins, they will result in high gas production. Now, the reaction period is another parameter where the biogas production is generally determined by the diameter to depth ratio of the digester. The diameter to depth ratio should be in the range of 0.66 to 1 to achieve better biogas production. and steering of digester contents is necessary to have better biogas production. Stirring will always increase the contact of the substrate with the bacteria, and it will increase the gas production, and it will improve the fermentation process. Now, stirring also avoids settling of sludge and scum formation. Now, scum formation avoids gas release. Continuous feeding will again minimize the problem of scum formation as they break up the charge and provide stirring. Now, occasional mixing can also be provided. This will mix the masses floating on the top to settle down with the deposits. Now, let us discuss about the advantages of biogas as a fuel. Now, if you see, they can readily mix with the air, it is light in weight and has high calorific value. The thermal efficiency is high due to uniform distribution. Biogas is a fuel with it has a high octane number, so it has a great potential as a fuel. It causes less pollution and the capital cost of the plant is also low. It is used as a household fuel and it is non-toxic to skin. The residue that is produced, it is considered clean and it is a cost effective fuel and can be easily supplied through the pipelines. It can also be used to generate electricity. Now, what are the advantages and limitations of the biogas technology? The biogas as a fuel can effectively replace firewood, and as a result you can indirectly reduce the deforestation. The biogas can also replace fossil fuels and thereby decrease the greenhouse gas emissions and other harmful gas emissions. Biogas again can be used as a source of energy, thereby reducing the harmful impact of methane on the biosphere. The waste and the cattle dung are placed in a confined space which prevents the contamination of surface and the groundwater. The waste material is ultimately transformed into a natural fertilizer which can be used in agriculture field, and they are rich in organic matter which can potentially enhance the growth of crop and plants. This again will reduce the soil depletion. Now, biogas technology also produces energy in the form of heat, light and electricity, and also the residue that is left out is free of pathogens because it reduces the contamination by pathogens, worm eggs and flies. Now, limitations of this technology is high capital cost, they are unrealistic, high expectation of users. Solar, micro, hydro and other renewable technologies have a positive side than the biogas technology. But if you talk about the municipal solid waste, they can serve as a better technology for converting the waste into a suitable byproduct. Now, this table shows how different types of waste can be used for biogas production. What is the solid level that is required for biogas generation, what is the temperature that is required, or which is the operating temperature at which the biogas generation can work, what is the percentage of methane that is produced, and what is the retention time. On the left side, if you see a lot of other cattle dung is there, the cattle manure, poultry manure, swine, sheep, forage leaves and sugar beet leaves are used. In addition to that, you also see algae, night soil. Night soil is nothing but the fecal matter or the excreta, and then it also talks about the municipal refuse. The poultry manure produces around 0.46 to 0.56 meter cube per kilogram of biogas within a retention period of 9 to 30 days, and the methane content ranges from 58 to 60%. The temperature requirement is 32 to 50.6 degrees Celsius. The maximum biogas production is obtained in swine manure, which ranges from 0.49 to 0.76 meter cube per kg within a very short retention period of 10 to 15 days. The temperature requirement is again 32.6 to 32.9 degree Celsius. The algae produces around 0.32 meter cube per kg of biogas within a retention period of 11 to 20 days, and the temperature requirement is 45 when compared to night soil that produces around 0.38 meter cube of biogas per kg of night soil with a retention period of 21 days. The biogas generation from the municipal refuse is comparable to that of algae and cattle manure, where it produces around 0.31 to 0.35 meter cube per kilogram of biogas within a retention period of 15 to 30 days, and the methane content ranges from 55 to 60, which is comparable to other. But in terms of methane content as such, if you see, sheep manure produces a maximum methane content within a period of 20 days. To summarize, at the end of this module, we have discussed about what is biogas, their composition, their properties, and what is a process that involves in the biogas generation, that is the anaerobic process, and what are the 4 different steps which is involved in biogas generation. We have also looked into the various microorganisms that are involved in the biogas generation. Then we discussed about the different types of biogas plants, like the balloon type, the fixed dome and the floating dome type biogas plants. We also looked into the advantages and disadvantages of each of the biogas digesters. Later, we discussed about the factors that influence the biogas generation, starting from your pH, temperature, retention time, reaction period, nutrients, etc. Now, lastly, we also saw what is the biogas potential or the biogas generation from various waste material. Then we discussed about the advantages of biogas being used as a fuel. Then we also discussed about advantages and disadvantages of the biogas technology. I hope this module would be of help to you. Thank you.